All right. So this is number what? Now problem number 4. We have 4 events. At least one event. That's one event. Another event. At least 2 events. Good. C is odd. Younger. And let's start there. And we're flipping 2 coins or 1 coin. Either way. So, free time? Oh yeah, free time. Free coin. Three coins. One coin. Unless you're shy. All right. Anyway, okay, so those are events, and then it asks you some questions about those events. But before we get to those events, let's draw a picture. So the picture we're going to draw is we're going to say, here's coin 1, coin 2, and coin 3. All right. We were interrupted. Now, we left off with there's 3 coins being tossed. So for this time, what I'm going to do is I'm going to list all the different ways we can flip, or the outcomes we can get from flipping the 3 coins. Okay? So one outcome would be that we get all heads. One outcome would be 2 heads and a tail. Or we can get head, tail, head. Or we can get tail, head, head. Now we're going to talk about in the class where order matters or doesn't matter and stuff like this. But at this point, they're assuming order does matter. In other words, heads, tails, heads is not the same thing as tails, heads, and heads. Okay? We're assuming that these coins are distinguishable. In other words, if you flip coin number 1 and you get heads, then you flip coin number 2, it's heads on 1 and heads on 2. I don't care which one. Okay? So that's another way to get it. Then we can possibly get 1 head. So there's 1 head, tail, 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 head, tail. And then there's 1, 2, 3, 4, 5, 6. 2 tails, 2 tails, tail, tail, head, and then tail, tail, tail. Now, as we'll see, there's a reason why there are 8 outcomes. If you remember the examples we did in class, when we did the 3 plants being idle or not, there was 8 outcomes possible for that. The 3 chips, good, bad chips that we were selecting of the 500 chips, we selected 3 chips. The chip could be either good or bad. And there was 8 outcomes on that one too. So that's not a coincidence. There are 8 outcomes with 3 puzzles. With 3 coins, each of them with a either heads or tails, basically 2 possible outcomes for each coin. Anyway, so we get all 3 of those. So now what I'm going to do is I'm going to say, let's make the event A, I'm going to put a red line like this. And I'm going to mark all these possible outcomes with that red line. So, does this have at least one head? No. There's one there, at least one head there, 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 there. Right? So right away, what's the probability of A? 7/8, right. Because if we assume, which we're going to, that this is a fair coin, then I have 7 out of 8 outcomes. Good. Now, we're going to use another color for B. Just erase this. Okay. We're going to use another color for B, and for B, I'm going to make this slash of green. So now I'm going to go through and make this slash of green for all the B's. At least 2 heads. These 2 heads here. Right? At least 2 heads here. Here. There's at least 3 heads. Right? Okay. So that's green. Now, what's the probability of getting a G head? 1/2, right. Now, we use another color for C. C, I'll do this vertical line. And so this is heads or odds. So there's an odd number of heads here. There's an odd number of heads here. 1, 1, and 1. And what's the probability of C? Also 1/2, right. Okay. Now, question. What's the probability of not A? Probability not A. So using what rule? What rule are we going to apply? Negation rule, right? So 1 minus probability of A is probability of not A. Question. And you know the probability of A, right? So 1 minus 7/8. Good. Second part. What's the probability of A and not C? A and not C. So we're going to do this 2 different ways. The first way is visually. All right. So the first way is we're going to do this visually. First I want to say, okay, where are all the A's? All the A's are here, 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 here. In other words, every place where I have A, 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 A. Right? And not C. So I want to go down here and mark everything that's not C. And I'm going to use blue squiggle for this. Okay? So we use this vertical line for C. Now I'm going to write everywhere I don't see B. That's from the right. So there's not blue. There's not blue. There's not blue. And so I want A and not C. So out of all these outcomes, which one has a blue squiggly and a red horizontal line? Those 3, so the probability. That's one way to do it. That's one way to do it. Now we're going to use algebra. The reason we want to use algebra to do it is because although I can draw this and it's super clear, as soon as we get into things that have more than 2 possible outcomes, die or something more complicated, or we're flipping this coin
1,000 times, it's going to be very difficult to write out by hand all the different ways. So we're going to have to come up with ways. We're going to have to come up with ideas on how to produce the number of ways we have in the. And that's what section 1 is. Okay? But for right now, we're just checking ourselves. So we did that visually. Now we're going to do this with the algebra. So A and not C. A not C. How else can I write that? Well, if you go into the notes I provide on here, I have lots of things on there. One of the things is the set sheet, which is extremely useful, but I also gave you a little description of A and not B. So I gave you a nice little thing where I did this, where I did this visually. And also, I'll see, A not B is the same thing as other minus. This is the same thing as the probability of A minus probability of A and, in our case, C. Okay? And that's exactly what we did visually here. Here are all the A's. And now I'm going to subtract. So A was 7. Right? 7 minus, what is A and C? A and C is oh, sorry, yeah, I was looking at the not C. Yeah. So yeah, I hope it's 4 8. Right. So where does the red vertical or horizontal lines and the blue horizontal lines both appear, and that is, you said 4 of them. So that's 4 divided by 8. 3 eighths. The algebra will never fail you. Pictures will fail you. It's good to start with just so you can get your feet wet, but then you really need to go to the algebra and make sure you understand that. Because this is what we're going to do. Sometimes it's not easy to draw. You notice also that this thing I drew here is basically a Venn diagram. It doesn't have to. I'm shading in. Okay? So let's look at the last part. See. He says, what's the probability not A or B or C? So now, this is the union of 3 events. If you have the union of 3 events, we already went through this, but just for the sake of this thing, I'll go through it again. This is written in your book on page 29 of the book has union of 3 events, and basically you have probability of the first event plus probability of the second event plus probability of the third event
minus all the intersections between any two things. So A, C, and B plus probability of F minus. Minus probability of not A and C minus the probability of minus the probability of B and C plus probability of all of them. A, C, and B, and C. Intersection of all three of those. And that's how you do the last problem. Now, here's a way, so we can figure all these things just like we did before. But let's take a little bit of a shortcut. Realize if I have at least two heads, do I have at least one? Right. And so if you look at our outcomes, where all the slashes for the A is, the pink or the red slashes, notice that the B's, in at least two heads, are within them. In other words, B always, that means that our event A has the event B contained within it. And so therefore, the probability of A and B is just what? Probability. Right. Because if B is true, A is automatically true. But if A is true, that doesn't necessarily mean that B is true. And so therefore, this is a little shortcut. This is the example I did with the dice rolls. I said the probability of getting a 3 and it being odd. And I showed that, right, 3 is an odd. So if 3 is true, you're already including the odd. Okay? So now if we do that, and we say, okay, we have not A. And not A is easy. Not A, which I'm going to represent as a red squiggle, right there. Right? There's only one thing. So actually, this starts becoming real easy. What's the probability of not A? 1. Okay. What's the probability of B? 1/2. The probability of C? Right. Now notice those don't add up to 1. Why? Because these are not mutually exclusive. What about not A and B? Okay. So I want not A, which is that red squiggle, and it has to have these green slashes. That's very easy to write. There is none. Minus not A, which is that one, and C. That's 0, 2. B and C. So I want green slashes with blue slashes. So here are the 4 green. All right, there's only one where the green and the blue are. So that's B. And then I want not A, and it has to be B, and it has to be C. And that's 0, because not A doesn't share anything with anybody. So this is 0. So I have okay. Any questions on this?
clear?
Yeah.
All right, cool.